So for part A of the exercise in question, they want us to verify that this truly is a solution to this differential equation. So let's make some substitutions. Now, before we actually do that, let's establish what the derivative is. So here, the derivative would be, well, c is a constant, goes along for the ride, and the derivative of the exponential is itself times the derivative of the exponent, which is -4. Constant goes to 0. So this is here the value of y prime ce to the -4x. Let's just keep that in mind. So let's go back over here. So let's see if this, in fact, is a solution to this equation. So y prime gets replaced by this here. So I have -4 ce to the -4x. And then I have addition 4. And then what replaces y? The initial value of y, ce to the -4x plus 35 cents. And all of that is supposed to equal 1.4. Let me just separate this from the pack. So let's see if this is true. Now, maybe we can use the distributive property. And then we, of course, have elimination between these terms. And so that 1.4 is indeed equal to itself. So that shows that this is a solution to this differential equation. And then part B, they wanted us to find to solve the initial value problem. So the problem here is that we know what this is, we know what this is, we know what this is, we don't know what C is. And that is the purpose of this fact. So recall that this is your input and this is like your output. That's like your X and that's your Y. So let's make some substitutions into this problem where 0 goes in for X and 2 goes in for Y. So this is like part A. Try to organize ourselves here. And this is part B. So again, 2 goes in for Y and 0 goes in for X. And let's see. That exponent is 0. E to the power of 0 is 1. 1 times C is C. And then you can subtract that from that. So we have C equals $1.65, which can then be substituted back in there. So the particular solution to this initial value problem is the following, like that. There that is. And then for part C, I think they actually wanted you to graph, y, this there. So you can rely on a grapher, Desmos, one of your fancy TI calculators, whatnot. So I would bust that technology and I would use a grapher to see what this looks like.